Hello student. Now in this class we are going to read about composition of function. In previous class we have defined as the function, the one function, onto function, into function and many one function etc. Means function, injective, bijective, surjective etc. Now we have to read the composition function. Here composition means composite of two functions, means when two functions is combined to each other, then the new function is made and the new function is called composition of two functions. Here definition is given as if any two functions, means two functions are given. Suppose that one function is f and second function is g, and domain of function f is a and codomain of function f is b. Domain of function g is b and the codomain of function g is c. Here examine that the function a to b and function b to c means it is the condition for composition of two functions. It is necessary to codomain of first function will be domain of second function. If codomain of first function will be domain of second function, then the two functions can be combined and the resulting function is called composition of two functions. The definition is defined as, and if any two functions, function f and function g, are given such a way such that function a to b, means function f is defined as state a to state b and function g is defined as state b to state c, then the function f and g can combine and the result can get us the is called composition of two functions. And the composition of two functions, function f and function g, is defined by GOF, a to c, means in the composition of function f and g is called GOF. Here the composition of f and g is defined as GOF, but in the reverse process, if we define composition of g to f, g and f, if we define the composition of g and f, it is reversed, FOG. It can written as FOG. Composition of f and g is written as GOF and composition of g and f is written as FOG. Means composition of GOF means composition of f and g. In this composition, the domain of GOF will be domain of set f, on that set f, and the codomain of the GOF will be the codomain of second function, means second function g. It is defined. It is the definition of the composition. Suppose that we see and it is defined as GOF. If x is element of set A, if any element are given and that element is element of set A, means x is element of x is element of domain of the function f. If x is element of domain of set f, then we can define as GOFX. It gives the rule to get the image of x in set C, means composition of set C. So composition of two functions. We are getting the element from composition of two functions by any rule, and the rule is defined as g of x will be equal to g of fx. It is the rule for finding the image of the composition of two functions. See about an example. Suppose that function f is given such that it is three sets are given. It sets 1, 2, and 3. Set B given. Suppose that 1, 4, and 9. It is C. And C is also a set which is given that 1, 0, 3, and 8. Here three sets are given, and the function defined as A and B. The first function defined by set function A to B, and the second function is defined by function B to C. These two functions are given, function A to B and function B to C. Are given such that f is defined as element 1 is related with element 1, element 2 is related with element 4, element 3 is related with 9. It is one function and in on 2 also. And function g is given as 1 is related with 0, 4 is related with 3, and 9 is related with 8. Here two functions are given, function f and function g. Now we have to find the composition of function f and g, means we have to find g of f. Now define g of f. G O F X. G O F. We have to find G O F. Then we have to find G O F X. Here X is the element of domain of the first function. Means first function is F and domain of F is A. F is A. Therefore the X belongs to set A. Means we have to put the value of X from set A. Then we find the next element. G of x is equal to G of fx. This implies G of f. Put the value of x from the domain of the first function, means set A. Since first element of set A is 1, therefore G of f1 is equal to G of f1. We see from the first function f1 means image of image of element 1 is found that 1 means g1. From second function we have to find the image of 1 from second function. From second function image of 1 is 0, means it is 0. Means g of f1 is 0. Means composition of according to composition of two functions f and g, the image of 1 we find that 0. And now g of f, the second element 2 means g of f2, means g of f2. From first function the image of 2 is 4. We get the image of 2 is 4. Then g of f2. Now g f2 means g f2 is equal to 4. It means we have to find g4. We see from the second function. In the second function the image of 4 is 3, means g4 will be getting 3. Hence the image of the element 2 from the GOF we find the element 3 from the set C. Now we have to find the third element, image of third element. Since image of third element is 3 of the domain of the GOF. First, third element is 3, means GOF3. GOF3 is defined as G of F3. From first function, we examine that the 3 has image 9, means F3 will be 9. We put the value of F3 in the GF3 equal to G9. From second function, the image of 9 we get as 8, means G9 equal to 8. From this, we have find the all images, means all images of the element in set A in the set C. It is the composition of the function f and g. Hence, the GOF is getting that 1 is related with 0, means GOF1 is equal to 0, means for one image we will get 0, means 1 0. Similarly, GOF2, I found the image 3, means 2 is 3. 2 is related with 3. Similarly, 3 is also related with 8. According to this example, we found that the GOF equal to 1 0, 2 3 and 3 8. We see about the given set. 1 2 3. 1 2 3 is the element of set A, and 0 3 8 is the element of set C. Means GOF means composition of F and G is a set which is defined on the set A to set C. Now we can find the reverse composition, means FOG. FOG can define as the composition of G and F, means composition of G and F will be defined as FOG. GOF is the composition of function f and g, and FOG is the composition of function g and f. Now we find the composition. If FOG is defined, FOG. What is FOG? FOG is defined at the element C to A. Set C to A. FOG C to A. And FOG defined as FOG x will be equal to f of gx. We can find FOG. Since domain of FOG is set C, means every element of set C can be put at the place of 0. But we find that 0 is not related with any element. Hence, from this situation, the FOG cannot be found. Means FOG cannot exist, because the relation between set C and set B is not given. If relation between set C and set B are given, then we can find the FOG. But in this situation, I cannot find the FOG. Now we see about some examples. Now we discuss at the example. Suppose that a set is given when elements is 1, 2, 3 and 4. Set B is also given that set B is not given in the question only one set A is given, and the two functions are given that function f is equal to two functions are given such that function a to a and second function g is also a to a. Means set a is related with set a from the function f, and the set a is also related with set a from the function g, and such a way function f is given that function f equal to 1 4 1 4 2 1 2 1 3 2 1 4 2 1 3 3 3 3 and 4 2. G function g is given that 1 3 means image of 1 equal to 3, 2 1 3 2 and 4 4. It is given. We have to find GOF, FOG, FOF, etc. We have to find GOF. GOF is the composition of function f and g. FOG is the composition of function g and f, and FOF is the composition of function f and f, composition of f and f, composition of f and g, and composition of g and f. We have to find first. We have to find composition of GOF. Since GOFX will be defined as G of fx, we have to put fx from the function f. From the function f, the image of 1 is 4, means GOF 1 is equal to G of f1, means G of the value of f1 means image of 1 is 4, so G4. From the second function means G is the image of 4 is 4, image of 4 equal to 4. Hence the from the composition of the function f and g, the image of 1 we gets 4. GOF2 is the second element of the domain. GOF2 is equal to G of f2. F2 we can find from the second function. The image of 2 is 1, means G, the value of f2 equal to image of 2 is equal to 1, means G1 from G of f2. Image of 2 equal to 1. Image of 2 equal to 1 means G1. G1 is equal to from second function 1 and 1 G1 is 3. G1 equal to 3. Now we have to find GOF, the third element 3. GOF3 means G of f3, means from f3 means from second first function. F3 means image of 3 is 3, means G3. From the second function G3, 3 is related with 2, means 2. Similarly, GOF, the last element of the domain A is 4, means GOF4 is equal to G of f4, means G of f4. F4 we can find the from first function means 4. Image of 4 is 2, means G 2. G4 equal to 2. From the second function, the image of 2 is 1, means G2 is equal to 1. So therefore, we find that GOF function is defined as 1 is related with the element 4, 2 is related with the element 3, and 3 is related with the element 2, and last 4 is related with the element 1. It is the composition of F and G. In problem 2, we have to find FOG. For FOG, we have to find the A to A. FOG also is the function whose domain is A and codomain is also A. According to definition of FOG, f of gx equal to f of gx. Now, from second function, gx means the element of codomain. Element of codomain is also from set 1, means FOG1. First element of the set A is 1. FOG1 is equal to f of g1. From the second function g1, 1 has the image 3, means the g1 equal to 3, means f and g1 equal to 3. It means f3. Now in the first function, the image of 3 is 3. Here, hence the image of 1 equal to 3. Now FOG for element 2 means f of g2. From second function, the image of 2 is 1. Therefore, if g2 equal to 1, then f g2 equal to 1. From first function, f1 means image of 1 is 4. Means f1 equal to 4, it is 4. From FOG for third element 3, FOG 3 means f of g3. From second function, the image of 3 means g3, image of 3 is 2, means g3 equal to 2, means f2. From first function, the value of f2 means image of 2 is 1. Therefore, f2 equal to 1. Now, we have to find the image of last element 4, means FOG4. FOG4 is equal to f of g4 is equal to function of g4. G4 we can see in the second function, the image of 4 is 4, means g4 equal to 4, means we have to find f4. f4 from the first function, the image of 4 is 2, means f4 equal to 2 equal to 2. Therefore, FOG is a function whose elements are 1, 3, means 1 is related with 3 and 2 is related with 4 and 3 is related with 1 and 4 is related with 2. Second condition. Now, in the question number first, we have to find the third function, and that is FOF, means composition of F and F, means composition of F and itself F. So therefore, we have to find function FOF. Since FOF x is equal to f of fx, means first function is f and second function is also f. Domain is a and codomain is also a. This implies we have to put the value of x from the set A. From set A, f of f1 from the first function f1. 1 has image 4, means f1 equal to 4, means we have to find f4. f4 equal to 2, means image of 4 from the function first is 2, means f4 equal to 2. Now function is f2 is equal to function 2 f2. 2 has image 1, means we have to find f1. Image of 1 is 4, hence f1 equal to 4. Now we have to find f3, means f the image of 3 from the function, image of 3 is 3, means f3 equal to also 3. f of f4, it is the last element of the domain, and f4 the function from the first function, the image of 4 is 2, and the function of 2, f4 equal to 2 has image 1, therefore 1. So therefore we have found the FOF as a set which element is 1, 2, other 2, 4, 3, 3, and 4, 1. It is the example of function.